So the very first question is, why would you change your data or range into a table? The answer is very simple. It improves readability, reduces rework, and increases your efficiency. Let's understand all of this with a few examples. So here we are calculating the sum and average of our sales data, which has 10 rows. When we add 5 more rows to our dataset, let's copy the last 5 rows from here and we will add it to the original one. The sales and average are not changing. Ideally, we would want the new data to be considered every time it is added. Now we have no option but to go back to our formulas again, change the range to ensure we are getting the correct sum and average. This is kind of a problem. We have to update our formulas every time we are adding new data. Let's look at another example. Here we have used a VLOOKUP formula to fetch the product price on the basis of product ID. Now a new product 11 was added to the product sheet. Let's quickly add it here. And now when it was sold in the transaction table, our formula could not find its corresponding price. This is because the range we have used in our VLOOKUP formula is static. Let's look at another one. Here we are creating a pivot table on this dataset. We will select the range. We will click on insert and let's insert a blank pivot table. Now let's calculate the region wise sales by dragging region to rows and we will drag sales to values. Now let's add some more data to our transaction dataset. I have already prepared the data in another sheet. Let's copy it from here. Now even if we go ahead and refresh our pivot table, these aggregated values won't change. And this is because we have explicitly hard coded our table range between these cells. You can click on change data source to confirm this. So every time new data will be added, we will have to go back and manually update the boundaries or range of our dataset to include the new data, which is of course a big problem. Let's look at another scenario. Here we have some product names and their corresponding sales, and we have created a chart demonstrating the product and their sales. Now when we are adding a new product, let's add product 11 and its corresponding sales. The chart is not getting updated. But if we change this dataset into a table and then if we create a chart on top of it, that chart will be dynamic. Let's verify it. We will delete this chart. We will convert our dataset into a table. And now let's create the same chart again. Now when we add product 12 to our dataset, it is reflecting correctly in the chart, which is one of the primary purpose of Excel table. It reduces our rework by making our dataset or range dynamic. Whenever we add new rows or columns, the table boundary will automatically update to include the new data. Let's look at the other examples again where we faced issues earlier. So for the first one, we converted our dataset into a table and let's again take the sum and average on this column. Now when we add new rows to our dataset by cutting and pasting from here, the sum and average formulas are updating automatically, and this is because the formula is trying to take the sum and average till the last value of this column, which is getting updated automatically when new data is getting added. Similarly for our VLOOKUP, we converted our dataset into a table and we use that table as our VLOOKUP reference. Now when we will add new products to our dataset or table, the price will reflect correctly in our transaction data. The same goes for our pivot table as well. If we change the base transaction data into a table and then we create a pivot table on top of it, you will notice that instead of hard coding the cell values, it is just specifying the table name. Now when new data will be added to the base table, we will just have to refresh our pivot table and the aggregated values will be updated automatically. All of this is happening because the boundaries of our dataset or range is updated automatically when new data is added into an Excel table. So the takeaway from this example is that our range becomes dynamic when we convert it into a table. Before we talk about some of the other advantages and basics about tables, I want to demonstrate the dynamic range concept with another example I absolutely love. So, a company is operating in 3 cities and we have created 2 drop-down lists using the data validation feature. For the first one, we have used the normal fixed range, and for the other one, we have used a table. Now the company started operating in one more city, so a new value was added to both the dataset. If we look at the one where we used table cells for our data validation, it automatically picked the new value, while the other one would require a change in the formula to pick this new value. I hope these examples clarify the concept of dynamic dataset boundaries and how it helps us in avoiding rework. Let's talk about the next advantages of Excel table. Here we have price and quantity. If we want to calculate the sales for this transaction, we can simply multiply the value of these two cells. Now we performed the calculation in a single cell, but it got replicated to the other cells automatically. Basically, when you convert your dataset into an Excel table, Excel understands that these rows and columns are related. This record or row is an individual transaction of our company, and this column contains the sales for the transactions that are happening. So you write your formula once and it gets replicated automatically to the other cells in the same column. We can change the name of our column as well. This concept basically is also known as calculated column. In this case, we calculated a new column on the basis of our existing values. If you have worked on any relational database or any ETL or reporting tool, you will be able to easily relate to it. We can create more columns like month of sales. We can use the text function to get that, and our calculated column is ready. So that's the second advantage. You write your formula once and it gets replicated everywhere. Let's look at 3 other advantages quickly. So when we have huge amount of data, we explicitly have to freeze our top row so that our headers are visible when we scroll our data down. We do not have to do that if we have converted our dataset into a table. Excel automatically freezes the first row for us, making our dataset more readable. Also, a lot of people who start learning Excel after working on SQL complain about these cell references, A1 to A10 and so on. When we convert our dataset into a table, it becomes much more easy to access our data. For example, here if we want to access this table, we just have to write is equals to transaction data. Transaction data is the name of this table and it returned everything. If we want to return the sales column only, we will write is equals to transaction data bracket open the total sales column. And if we want to select the sum of our sales column, we can write equals to sum trans data bracket open, total sales column. Now when the values will get added to our table, this formula will update accordingly. When we are working in SQL, we are used to referring columns with their names. This structured reference of having a column name is relatively easy in comparison to using cell reference. Another cool feature with tables is slicers. Yes, we can use slicers on our dataset if we convert it into a table. This will help us filter, slice, dice, and validate things really quickly. Remember, this is not possible if our dataset is a normal range. Let's apply slicer on product, region, and employee name. Let's organize them a little bit. And now we can slice and dice our data in any way we want. This comes in really handy when we are validating our formulas or any calculations in our dashboard. A couple of other use cases that come in handy with Excel table are format replication and totals. Let's see them. So here we have this table where the column status can have three values: success, in progress, or failed. We have applied conditional formatting on this cell. Now let's convert this dataset into a table, and when we insert new rows, the formatting will be copied automatically. We have talked a lot about the advantages of Excel table. Let's look at how we can create them and the options we have with them. And then we will talk about some of the limitations and when we should avoid using Excel tables. So here we have this data set, and in order to convert it into a table, we can either go to home and format our data as a table, or we can use the shortcut Ctrl T to do the same. Excel checks if we have headers in our dataset. If we do not have the headers, Excel will introduce the headers with names as column 1, column 2, and so on. Since we have the header, let's press Ctrl Z and we will create the table again, and this time we will choose my table has headers and our table is ready. As soon as we create the table, Excel introduces this table design tab. We have a bunch of options we can choose from. We can pick any of the layout, or we can choose none as formatting. Here we will have the same format, but these additional buttons which will allow us to filter our data. We can also remove the filter button if we want, and we can also decide to remove the header row. The header row is not actually removed, it's just hidden. Let's bring back both these options. Now we can choose to band our columns or rows. This will provide a color to alternate columns or rows, making it more readable. We can highlight the first or last column. We can give the table a name of our choice, and we can also decide to add a total row. We have an option to convert our table back to the normal range. Let's not do that, and let's remove the total row also for a moment. And let's look at this blue symbol right here, which indicates the boundary of the table, and it is the most important part because it updates automatically when new data is added. Try exploring these options a little bit on your own. And now let's talk about couple of problems we face when we are dealing with tables. So currently tables do not support dynamic array functions. We know that dynamic array functions spill the output in the neighboring cells, and we also know that if we write a formula in a particular cell in a table, it automatically gets replicated in the entire column. Let's see this with an example. If we write sequence 1, it is working fine because the output is only confined to the same cell. But if we write sequence 2, the first cell will try to spill output in the next cell where we already have this formula again, and we will start getting spill error. So if you plan to use dynamic array function in your range, you cannot convert your range into an Excel table. Also, if your dataset is huge, let's say more than 100,000 or 200,000 rows, using Excel table may slow down the data processing a little. So you should carefully evaluate using tables in such cases. I hope this has been helpful in understanding why and when should we convert our data range into a table. If you still have any questions, please drop them in the comment section.